Hello, my friends. My name is Anton from pygnm, and today we continue our video series about gNMI, the Python library created by our project for you to help you to manage the network elements using the Python and gNMI protocol. So in our previous series, we have covered such topics as working with the Python directly with this model and issuing all type of the operations such as capabilities to collect what the network element supports in terms of Pyjami models or gNMI itself, get how to collect the information about the configuration or running counters and so on, so operational data set, which is changing the configuration of the network element either by imposing new, modifying the existing, or removing the configuration. And finally, we have taken a look into the telemetry side, so how you could collect the streaming telemetry from the network elements using the JSON encapsulation or native protobuf. So with this, we have covered all the basic operation, and now we'll start looking into possible integration to give you some ideas where pygnmi could help you further. And today we will take a look onto the Nornir. So we'll take a look how to create the tasks for Nornir and in general how you could use pygnmi in your Nornir ADS. Nornir probably one of the most popular network automation or general automation frameworks, which is used quite a lot, especially in the networking field. And it is widely used, and gNMI is something that's getting into reality in the data centers and service providers field. We decided to show you how you could integrate. The spoiler, it's very easy, and we will show you today how to do that. Just to remind you the topology, we have the gNMI server, which is having pygnmi installed. It has both IPv4 and IPv6 addresses, and we have two devices in our lab, Arista EOS switch and Nokia SRS router, which having IPv4 and IPv6 management address. As you might remember, pygnmi is working over IPv4 and IPv6. So let's get started with our lab today. So what we will do, we will show you how to create the tasks which are relying on the pygnmi and how their parallelization is working. So taking a look to our screen right now, you may say that we don't have any codes open so far. So all the previous results you see on the left-hand side, and you could also get all these messages and all these files into our GitHub repository, which contains the pygnmi. So we will start today from the scratches as we are integrating with Nornir. So we'll create a new folder, which we would call effectively Nornir. And this folder we will use to structure our lab today. So we start with installation of the pygnmi. We don't have it easy right now. So pip install pygnmi. So it is collecting the latest version. It also collects the related libraries, which we are using, such as gRPC IO to build the transport. And we will also install the Nornir, the latest version, which is also available into pygnmi. So the Nornir version that we are using is 3.0.0. So we haven't tested the capability as compatibility with the previous version. It might work. We honestly don't know. If you'd like to test, just test and give us feedback. So to start working with Nornir, we need to have just a few basic files. So first, we will create a folder which will be called inventory, which we will contain effectively our inventory. And we will also create the config file, config.yaml, which is used by the Nornir to store the configuration. So in the config file, we will have the basic setup. I'll just copy it from the MyLab. So if you're familiar with the Nornir, you'd see that we are using simple inventory, so nothing specific local files, which we'll create in a moment. In fact, we need to have, for our lab purposes, only a single file hosts YAML located in the inventory folder. From the runner perspective, we are running in the threaded option with 20 workers, so we rely on the capability of the parallelization or threading, which the Nornir gives us. And this is why we decided to integrate it, because we could benefit out of it, out of this capability just directly out of box. So we create the file, the host's YAML, right? And in this file, we will structure the inventory that we have in our lab. So if you are familiar with Nornir, you would know that the structure of the files, inventory files, is created in the way that we have entry for each host, which is the name of the device. So in our case, we have gNMI EOS1 and we would have gNMI SR1. So they are following basically the name that you see in our lab. So EOS1 and SR1. We are adding the prefix gNMI just to highlight that this device is gNMI speaking. So then inside each device, we need to add a few keys such as host name. In our case, we would use the IP address because we are using this key to connect to the network element. So for Arista, we provide IPv6 address out of our topology. Then we provide also port because we need to specify onto which port we have the gNMI protocol running, and we also are adding the username, password, and we could also add the details about the platform, so that depending on the platform, you could play a bit with the type of the, not the type of the messages, what the encapsulation supported, and so on. So platform in our case will be Arista EOS. We will be using the same names as we have used previously in our previous demos. So for SR1, we would provide a IPv4 IP address. So 169.169.255.11. So, and we are having different credential there, which we would specify, and different platform type. So this is Nokia SRS. So this would be our inventory file, which upon usage of the config file would be imported into our script. So we are ready in terms of we have created the config and inventory, and finally we need just to create the playbook, sorry, not the playbook, the Python script, which will rely on the Nornir and which we will be using to build, basically to interact with our network element. So let's call it test PY. So we start with the providing, as usual, the path to the Python using the shebang, so user bin and Python. Then we are importing the models that we are going to use, which will be in our case the models such as import, so basically our own model. So from PY gNMI, we and the submodel client, we are importing the gNMI client. Then from Nornir, we are importing init Nornir class, and from the Nornir core task, we are importing the task and result classes. So we would also add here the logging model, which just needed in order to see the logs of the Nornir execution. So now, well, this is our model. I think I need to put it in the proper place. Afterwards, we would create the user-defined functions, which would be effectively our tasks for Nornir. So we'll do it in a minute. So user-defined tasks. And we finally would have our main body, where we will be building our execution flow. So first we'll create the object, which we'll call NR, so which will be created out of the Nornir and config file is the config file in the same directory with our test py, which we have created just a couple of minutes ago. So after that, we would need to already start doing execution. So we need to define now the task. So how we do it, let's say we will call the task gNMI. Let's start with the capabilities. So basically the simplest one for us to collect the information. And the input for the task, we will be providing the information such as task out of task class type, and basically that's it. We don't need to provide anything else. The result should be then stored and the result type of object. So we'll create the placeholder like return result, and the things which we are returning out on this class would be host out of our task host, and result would be coming out of our variable that we will create in a moment. So now within this task that we will be executing with the Nornir, we need to create what exactly we are doing. And this is where comes the thing that what we have discussed previously in our previous demos. So we effectively create using the gNMI client and all the parameters that we need to provide to it. So let's start providing target, which is a tuple, and we need to provide the IP address and the port. We are relying now on the Nornir inventory. So what we do, task host, and then host name and task host port. So this would take information out of our host file, so host name and the port, and create the connectivity towards the network element. Then we provide also the username, which is coming again out of task host username. We're also providing password. So password also coming from the same inventory, right? So and finally, we are so far using the insecure connectivity type. This would create for us the task exactly in the same way we have done it in the previously. So when we was creating our capabilities or get or call or whatever, and this object which we have created, the GC, it is our interaction with the network element. So what we need to do now, just the last string. So R would be equal as GC capabilities. So we don't need to provide any inputs, I mean, additional parameters to the capabilities method. It will collect the information, what is provided as a response in the capabilities call towards the network element, store it in the R variable. And this variable we are sending back as a result of this task execution towards our main script. So now in our main body, we'll create just, let's say, a result variable, which would contain the result of execution of this task. So we say that the task in this case is gNMI capabilities, the one that we have created. And basically that's it. So now if everything is accurate, we shall see the result as information collected from the network elements. So to recap what we have done, we have imported the Nornir init Nornir class and then task and result classes, which are the basic building blocks of the script. We have also created the gNMI client, so the class out of our pygnmi library, which is building the connectivity or the gNMI towards the network element and allows you in easy format, Python native data classes, not the classes, so data like dictionaries, lists, send the information to the network element and collect it back. And we have created the task, which would be doing for us connectivity towards network element or the gNMI and collecting the capabilities. So let's give it a try for this script. So I need to jump to the folder Nornir, and I could now run Python test. So we see that we are provided with output that we have collected some results, so meaning something has worked. You might have seen that just right after execution, we have a new file, Nornir log has popped up. So again, if you're familiar with the Python, with the Nornir, you know that this is where the details about the hosts is provided. And you see that we have details telling us that for 2 hosts, we have gNMI capability task executed. If we would have any error, you would see the errors here, you don't see error, which is a good sign. So what we do now in order to look into these details further, so we could, the way how it is structured, so we need to tell which network element we are willing to look into, I mean, the results of which, let's say it would be EOS 1. And then we just need to tell out of the list what are the results we are looking after. So the first result is gNMI capability. So we could now run our script, and you would see that you are getting the output of the capabilities. So the beauty of the using Nornir with the pygnmi is that Nornir is taking care about the inventory and multi-threading, and pygnmi is taking care of the gNMI capability itself. So you see that you're getting the result. So we could change here that it is for SR1 rather than EOS, and we run the test, and we are getting, you see here, the output of this device. It doesn't mean that the script is run against only one device. No, it's run against 2 devices simultaneously. If you have 10, it would run against 10 simultaneously, because in our config file, we have amount of workers is 20. And the result is just stored in the output results. All the tasks executed for all the devices, you have the information collected, and you have the result is stored in their object. So you don't need to think about how to access this data. So upon this variable, you could access this data and then integrate it with Netbox or whatever. Let's probably add one more task. So we will copy just this one to show you further how easy it is to use it with the Nornir. We will call the second task get. So at the input to the get, we need to have some extra arguments. The argument that we need to have is pass, which contains a list of the strings, which contain the pass towards the network element, which we are not the network element, so those are resources within the network element which are to be pulled. So let's pass the information about these tasks from outside of this task. So we'll provide the input needed within the get method, which is pass, to the variable pass, which will provide outside of the task. And we will add here a new task. So let's say result 2. And it will be as nr run task gNMI get, and the pass that we would like to provide extra would be just a list of the strings. So let's say we'd like to collect information about the open config interfaces. So what should happen in this stage? We will pass this variable obviously to the boss task, to the boss network elements, both of them supporting open config. That is why it would work. Otherwise, we could store this information as an data per hour within our inventory, so that we could add even further customization. And we shall give the results of the configured interfaces. Let's try this. Run execution of our script right now. And you see that we are collecting the information about the interfaces. You see what are the variables. We have interface, name of the interface, further details that are contained within the open config YARN model, which we are using in this case. And all the information, including both the configuration and the operational date, because by default we are collecting all elements, which is also the default gNMI behavior. You see all the counters or the packets when it has changed, and so on and so forth. So this is collected as set for the both elements simultaneously, and running it again, you see that the info is connected from the Arista as well. It is even slightly more, but it's again just what the network elements send to you. There are further possibilities what you could do. So you could structure this task into one big task. So use like parent-children relationship within the tasks. Everything that you know about Nornir, you could apply here. By the way, guys, we are starting the new network automation training. There's not the new training, but we have separate training for the Nornir automation, where we covers you the basic of the Nornir and how you could use Nornir in all sorts of the network automation, including the CLI, netconf, gNMI, obviously, and the integration with netbox and other stuff. If you like this training, join. You will see much more compared to what you have seen today. Thank you very much for your attention. Stay safe, stay healthy, take care, and goodbye.